Good morning, everyone. How many of you have lots of data that you know you can get value from, but you don't have data science teams to help you with that? In this session today, you will learn about how you can improve your data analysis with machine learning without writing a single line of code using Amazon SageMaker Canvas. My work in AWS is in the area of machine learning. I've been with Amazon 6 years, and previously I worked in the Alexa team. Some of the things I will share with you today are things that I've also come across. And if you're dealing with similar challenges, I'm hoping that you might get some ideas about how to address them. Machine learning is powerful. There are so many areas where it is really changing the way we operate today. Forecasting demand. I will not go too far for this example. I will give you an example from Amazon. So Amazon ships billions of packages worldwide every year to more than 150 countries. Last year, on Prime Day, Amazon shipped 250 million items worldwide on that day. Some of them had to be delivered the same day and some the next day. 250 million items is a huge number. So how did the teams forecast demand? They used machine learning and they built models to forecast demand across a variety of products and make the right purchasing decisions. Fraud detection and credit cards. You may have received alerts from your bank when there was a suspicious transaction. Financial institutions use machine learning models to detect fraud patterns in transactions and take appropriate measures. Education. We are seeing a lot of edtech companies who are unlocking the benefits of machine learning to create adaptive learning models and offer personalized experiences to their users. And finally, supply chain and operations. I'll go back to the Amazon example. It's not just about forecasting demand. You also need to make sure that the products you bought are in the right country, in the right warehouse, in the right shelf. Again, the Amazon teams used machine learning to place the products as close to the customers as they could and meet the customer promise. But there are other use cases in this area as well. You can also use machine learning to monitor your network for anomalies so that you can take immediate action if something unpredictable occurs that may impact your delivery times. There are so many examples where machine learning is changing the way we work, and it is the most transformational technology of a generation. The truth, however, is that it's also complex. For example, you may have documents today that are filled out by hand that you need to process and digitize. Now, this problem is more difficult than it sounds because our handwriting is not the same. I probably write the number 7 very differently than the way you write the number 7. Luckily for us, we have machine learning models called neural networks that can do exactly that. They can read handwritten digits, letters, words, and exactly understand all the different handwritings and produce the right outcomes. Here on the screen, I have an example of such a model for you. It is a neural network that is being trained to recognize handwritten digits. Even for this relatively simple use case, this model is quite complex. So if we think about more sophisticated, more advanced use cases, the models get so complex that you need to have machine learning expertise and also spend sometimes months or even years of research before you're able to solve machine learning problems. What we hear from customers today is that they want to bring machine learning to a number of projects, to more projects than we have data scientists for. So if you are a data analyst, a business user, if you run a team of data analysts, you know that by bringing machine learning to your analysis, you can generate predictive insights, which will help you save thousands or even millions of dollars for your business and help your team and your organization. But you may not always have the skills required and the machine learning expertise skills you need to bring machine learning to your analysis. So what do you do in this case? The first thing you could do, according to what we've heard from customers in the past, is to hire more data scientists. Now, the reality is that data scientists are hard to find. And that's not a surprise at all, because machine learning is such a new area of technology. In fact, according to a LinkedIn report from 2020, the annual demand for AI specialists the previous 4 years grew 74% each year. That was twice as much as the demand for any other role. So what customers tell us is that when they have data scientists, they want them to focus on these critical, high-priority, complex use cases, which will help them with their business. And those who don't, it takes them some time before they can build data science teams. A second thing you could do is to get trained in machine learning or train your teams. Again, what we hear from customers is that the learning curve is steep. And that is because you need to have machine learning expertise, and also you need to have some coding skills. Most importantly, you need to understand the full machine learning development process. That process consists of 4 key steps. The first step is to understand the business requirements and be able to frame the problem as a machine learning problem that will unlock value for your business. The second thing you need to do, and that's the second step, is that you need to gather all this data you have, which in most cases is stored in different data stores. Bring them together and then do some data preparation so that the quality of your data is good enough to be consumed by a machine learning algorithm. This is the most time-consuming phase of this process. You need to prepare your data. Maybe you need to fill in missing values. Maybe you have incorrect values there. You need to understand which part of your data is really useful for your model and will impact your predictions later on, and maybe you need to synthesize data as well. Once you do that, you can move ahead to step 3, model development. In model development, you need to decide which algorithm you need to use, which means that you need to be familiar with concepts such as random forests or multi-layer perceptron, and also you need to have coding skills. Once you know which algorithm you want to use, you can proceed with experimenting, tuning the parameters of the algorithm so that you can get the best results out of that algorithm. And also, you need to be able to explain your model. You need to be able why your algorithm, your model, is making the predictions it's making, so that you have trust in your model and you also give confidence to your stakeholders. Once you are done with these 3 steps, you can go ahead and deploy the model in production and start using it to make real-world predictions, and you can also monitor your model and improve it over time. This is a lengthy process. Even if you have machine learning expertise, it can take weeks to months before you have a model in production. A third approach would be to use some of the low-code machine learning tools that are available in the market. What customers told us in the past is that these tools are built also for data scientists, and that's why the UX, the user experience, sometimes requires you to understand concepts like machine learning concepts. Also, most of these tools have licensing fees, which means you need to make upfront decisions around cost before you start using them. So all of these 3 approaches we talked about so far have cost. It can be cost in terms of resources. It can be cost in terms of time or in terms of fees. Our founder, Jeff Bezos, thinks that frugality drives innovation just like other constraints do, and that one of the only ways to get out of a tight box is to invent your way out. And that's exactly what we did here at AWS by launching Amazon SageMaker Canvas. With Amazon SageMaker Canvas, you can generate highly accurate predictions without writing any coding and without having machine learning expertise. Canvas has a visual drag-and-drop interface, which guides you through the steps of the process I showed you earlier. It also gives you the explainability you need to be able to explain your model and go back to your stakeholders and earn their trust with regards to your model. There are no licensing fees. So with Amazon SageMaker Canvas, you pay for what you use, and you are charged based on your usage, based on for how long you are logged into Canvas, and for the number of cells you use from your training data when you do the training and you train your algorithm. Amazon SageMaker Canvas, as the name suggests, is part of Amazon SageMaker. Amazon SageMaker is the AWS service specifically built for machine learning practitioners to enable them to quickly train, create, build, and deploy machine learning models. Since the launch of Amazon SageMaker in 2018, organizations around the world have produced billions of predictions. With the addition of SageMaker Canvas to the SageMaker portfolio, now we bring all of this SageMaker technology closer to the business users and the data analysts. Now, before I show you some demos of Canvas, I wanted to walk you through some of the key features. First of all, it was specifically built for analysts. We know that analysts are experts in diving deep into the numbers, using spreadsheets, applying domain expertise, and getting insights and reports back to the business users. With Canvas, they can bring their domain expertise and analysis skills to the machine learning process. If you're not familiar with the AWS console, that's no problem at all. With Amazon SageMaker Canvas, you don't need to use the console. You can log in with single sign-on by using your username and password as you would do in any other software as a service product. Canvas has a visual drag-and-drop interface, which allows you to import your data from different data sources. You can import data from your local computer. You can import data from object storage in the AWS cloud, from Amazon S3. And you can also import data from your data warehouse, again in the AWS cloud, Amazon Redshift, or Snowflake. Once you import your data, you can decide which ones of the columns of your dataset you want to use. You can do some basic preparation of your data, again, within that visual user interface. And you also get out-of-the-box visualizations to help to understand your data better. Let's move on to training. With Amazon SageMaker Canvas, you can have a model trained in minutes, literally. So that is because Amazon SageMaker Canvas uses AutoML technology behind the scenes to identify the right problem and find the best model for you. It also provides you with a feature that I really like. It's called Preview Model. With Preview Model, you don't even have to wait for a model to be trained to understand whether your dataset is good enough. It will give you, in a couple of minutes, insights about your dataset, its quality, and the estimated quality of your model. So you can, in a couple of minutes, decide, yes, I want to go ahead with this, or no, I want to go back and bring more data to my analysis. Once you have trained your model, you can make predictions within the same UI. So you have two options. You can make batch predictions, where you give Canvas a new data set, and it can predict the values you want. Or you can test what-if scenarios, so you can experiment with different values and see how these impact your predictions. Finally, you can optionally share your models with the data scientists. You can generate very easily a link within Canvas. You can send it to the data scientists, and they can open it within SageMaker. in case they want to check your model, look at the underlying code, or maybe they want to deploy your model behind an endpoint so that an application can consume it and other users can use it. So remember that four-step process we saw earlier? Now it becomes much faster and much simpler with Canvas. So the way it works, to summarize, is the following. First, you import your data to Canvas, and you join your different data sets as needed. Once you are happy with your data, you select what column you would like to predict, and also which columns you would like to use as inputs. Then you build your model, and behind the scenes, Canvas will do the heavy lifting for you. It will find out which is the best model for your problem type. Once that's done, you can use your model to generate predictions, and also you can see the outputs of your model so that you can use them to explain how the predictions to your stakeholders. Let's take a look at how this works with a very common use case, predicting common machine failures. So a lot of manufacturers and companies whose operations rely a lot on equipment want to recognize machine failure types as early as possible. And that's why we see a lot of customers in these areas who turn to machine learning because they can get predictive insights very quickly from machine learning models. What is different about these models compared to the more traditional analysis techniques is that they look at all the condition of a machine as a whole. They look at all the different attributes that may or may not cause a failure and the relationships between them to train a model, and then they can use this model to predict future failures. In this case, in this demo, I will be using a synthetic dataset from the UCI machine learning repository. And let's assume that I am a data analyst and I have historical data about the equipment in my organization. So when this historical data was recorded, we recorded the identifiers of each machine. We recorded the different attributes of each machine that define its condition. For example, the temperature, the rotational speed. And also, we recorded whether that machine had a failure or not, and whether it was, for those that had a failure, whether it was an overstrain failure or power failure. So I have uploaded this data set to the object storage in Amazon S3 in the AWS cloud, and I want to use it to generate predictions, which means that in the future, at any time, I can provide my model with new data about the machines I have, and the model will predict whether there is a failure or not and what type of failure. Great, so let's go to the Amazon SageMaker Canvas console to get started and create a model. So this is the Amazon SageMaker Canvas console, and I will click on New Model to create a new model. I will start with giving my model a name. So let's call it Predict Machine Failures. And now I see 4 tabs: Select, Build, Analyze, and Predict, which correspond to the 4 steps of the machine learning process we discussed earlier. First thing I need to do is I need to import the dataset with the historical data about my equipment. I'll just browse the S3 buckets and I'll find my dataset. It's called Maintenance Dataset. Let's take a look. So here we have, for each row corresponds to a machine, and we have all the details about the machine as well as the failure type. Let's import that data to Canvas. So it just takes a few seconds to process the data, and now that it's done, I can select the data set and proceed to the next step. Here, I need to specify the target column, which is the column I want to predict, its failure type. It can be no failure, overstrain failure, or power failure, and Canvas has identified this problem as a 3-category prediction. If for any reason you want to change the type, you can do that through the UI. I'm happy with the type, so I'll leave it as it is. at the bottom of this page, I can also see some statistics about my data set. So I can see here the value distribution for each one of the columns. And if I click on a column, I can get even more details. For example, here for rotational speed, I can see the value distribution, the number of unique values, the mode, and the standard deviation. Okay, let's close that. So moving on, I want to check the quality of my data set before I build a model. And for that, I will use the preview model functionality. With preview model, behind the scenes, Canvas uses a subset of my data set to generate some estimates about the prediction of the accuracy of the model I'm about to build, and the estimated impact of each column to the predicted value, to the failure type in this case. This model, the model I'm about to build, is estimated to have 99% accuracy, and below that you can see all the columns ranked by their impact. Product ID doesn't seem to matter that much, so I'll just unclick and remove it from my data set. Next, I will build a model. I have two options, standard build and quick build. In this demo, we will see quick build. With quick build, you choose speed over accuracy. Essentially, it will give you a model ready to use in between 2 to 15 minutes. And because it's so fast, you sacrifice the accuracy a bit. On the other hand, standard build, which we will see later, takes longer to execute, but it will give you the best accuracy possible. Okay. So what we've done so far, let's summarize. So we imported a data set with historical information about the machines I have and the failure types. I brought that into Canvas. Then I had a look at my data set. I did a preview model to evaluate the quality of my data set. I told Canvas I want to predict the failure type. And I started building a model. That took 3-4 minutes maximum. If you're familiar with machine learning, there may be some things in this process that surprise you. First of all, I don't know if you noticed, but the data set was imbalanced. A lot of far more machines didn't have a failure at all compared to those that did. And that's how the real world is. We expect that our equipment will not fail that often. This is typically an issue when we deal with machine learning algorithms. The second thing is that I didn't have to specify the problem I'm trying to solve. I didn't have to choose an algorithm. And also, the ranges of the values for some of these, the temperature versus the rotational speed, were very different. Again, these are very common when you do with machine learning, and when you have different ranges in your data set, then it can cause issues. Why this is not an issue in this case is because Amazon SageMaker Canvas uses SageMaker AutoML technology behind the scenes. So with AutoML, you can answer questions such as, what type of problem are we solving? How should the data be best prepared for best results? What algorithm is best for this problem? What are the parameter values I should use in model training? Okay, so now we can go back and see the results of our model. Okay, so this model predicts the correct failure type 99% of the times. Canvas also produces some outputs for you, and it gives you a breakdown of all the columns, same way we saw for preview model earlier, and you can dive deep and to understand how each column correlates with the target variable, in this case, the failure type. Okay, so I think the model is good, 99% accuracy. We can go ahead and make some predictions. What I've done now is I have another data set with the latest data from my equipment, the latest values for all of the machines, the temperature, rotational speed, torque, etc. I want to use that data set and predict whether my machine is going to fail or not. So I will select the data set from S3 the same way I did before. And in this case, it's a different data set. It's called machines in use today. We have the machine identifier, we have the product ID, the type of the machine, and then the attributes: air temperature, process temperature, rotational speed, torque, and tool wear. We don't know if this machine is going to fail or not, but we will try to predict it. Okay, generate predictions. And here are our results. The first column has the predicted failure type for each machine. The second column has the probability that this failure may occur. Why is this useful? I can immediately send my engineers to the machine with UDI 604 and say, please have a look. There is a chance this machine will fail. Let's look at another example, customer churn. So this is a very common use case, again, across industries. For example, media streaming providers want to predict churn so that their subscribers don't leave their service. Software as a service providers want to do the same. Marketing teams, maybe mobile operators, want to reduce customer churn and retain their subscribers. Employers want to be able to retain their employees. So by predicting customer churn, we can use machine learning models and answer questions such as, what is going to happen if I increase my subscription for $50? Or if I increase my delivery charge for $50? Which customers should I target in my next customer promotion? What is the best time of the day to target these customers? Which employee benefits should I invest in so that my employees don't leave the company? In this example, again, I am a business analyst and I work for a mobile operator. I will use another synthetic data set from the machine learning UCI repository, which was also mentioned in the book Discovering Knowledge in Data by Daniel LaRose. Let's take a look at our data set. This data set contains historical data about mobile customers. For each customer, at the time when this data was recorded, we have some information. We know where they are located. We know their state. We know how long they had been active with us as a mobile service provider. We know their phone number, which is a unique identifier for each customer. So we can tell customers apart using the phone number. We know whether they had subscribed for an international plan, whether they had the voicemail feature on, and whether they had received voicemail messages. And we also know how many times they had contacted customer service. In addition to that, we have some data around their usage and charges. This data is split by time of the day. So we have data for their day usage, evening usage, and night usage, and also data about their international calls. And finally, and most importantly, we know whether these customers were still with us or not at the time when this data was recorded. This is extremely useful information. I can now build a model which, in the future, at any time, will predict whether a customer is at risk of churn or not when given similar information about the location, service calls, and the customer's account and the customer's usage. Before I move on to the demo, I also wanted to highlight another point. In most cases, your data will not reside in a single data store. In real-world scenarios, we have data maybe in object storage, maybe in databases, maybe in a data warehouse. So you want to bring all this data together and find out which of the columns you want to use to make predictions. Amazon SageMaker Canvas allows you to do that, and I will show you how in the next example. So I will assume that part of my data, what you see in white on this slide, is saved in object storage in Amazon S3. And all the data about the customer's usage and calls and charges is saved in the warehouse in Amazon Redshift. Churn is also saved together with the account data in Amazon S3. So what I will do in the next demo is that I will bring both these data sources to Amazon SageMaker Canvas. I will join them using the unique identifier, the phone number, and then I can proceed and build a model to make predictions. OK, so I'm back in the SageMaker Canvas console, and I will give my model a name. I will call it Churn Prediction Model. First, I will import the data from S3. So this is my data set. Let's have a look. See here we have data for customers. Each row corresponds to a different customer. And we can go ahead and import that data. Next, we want to import the second data set from the data warehouse. So I click on Import, and I first need to add a connection to Redshift. So we'll get the details of the connection from my administrator and add them here. I need to provide the cluster identifier, the database name, the database user, the role ARN, and give my connection a name. And that's it. I'm now connected to Redshift, and I can select the table with the historical customer data. There it is. So I'll just drag and drop it. Again, it takes a couple of seconds to load, but I can preview my data set. And again, we have a row per customer, and we have all the information about their calls and charges and number of minutes they spoke on the phone. If you want to select a subset of this data set, we can do that by selecting exactly the columns we want to use using SQL. I will not do that today, so I will use the full data set. When I import the data to Redshift, I need to to Canvas, I need to give my new data set a name. So we'll just call it Customer Historical Data Redshift. OK. Now I have both my data sets in Canvas. So what I want to do next, I want to join them. Let's click on Join. On the left-hand side, I have all my data sets. I'll find the data set I want. That was number 1, the one from Amazon S3. And data set number 2 from Amazon Redshift. SageMaker Canvas is smart enough to understand that phone is a unique identifier, and it has already joined the data set based on that. Here you can see the columns of all the data of the full data set. And here you can see all the you can see how it's linked to the data set using Canvas. OK, so now I have my final data set, and I will give it a name. I will call it Customer Churn Full Data Set. OK, so once it's ready to use, it has 21 columns and 4,500 cells roughly. And I can move on to the next step and start creating my model. Same as before, first thing I want to do is select the target column. And in this case, it's churn. It has 2 values, true and false. And Canvas has already identified the model type as 2-category prediction. Again, at the bottom, you can see some nice visualizations about our data. Okay, I think the data set looks good, so we can go ahead and do a preview model. For this model, the estimated accuracy is 93%. So it predicts the correct target, in this case churn, 93% of the times. We have all the columns of our data set and their estimated impact on the prediction. And at the bottom, you can see that Vmail, plan, and phone don't really make such a big difference. So I will go ahead and just remove them from my training data. Again, this is an optional step. You could leave them in and see how your model performs an experiment depending on your use case, and maybe you have additional domain expertise you can bring in this case. Great. So the next step is to build our model. So in this case, okay, let's also have a look at the target value before we build it. So we don't have any missing values. So it looks good, so I'll just go ahead and build my model. And I will use standard build. As I mentioned earlier, with standard build, you may have to wait between 2 to 4 hours, but you get the maximum accuracy. So now I'm building the model, and Canvas will exhaust all the different combinations of potential models and hyperparameters behind the scenes to find the best model for me. Let's look at the results. 97.6% accuracy is the predicted accuracy in this case. Again, I can see all the different columns, but what I also wanted to show you is some more advanced metrics you can get in this view. So if you look at the advanced metrics here, you get some metrics that are very common when we speak to data scientists or ML practitioners, like the F1 score, the accuracy, precision, recall, AUC, and the table that helps explain the predictions. You can download these, and you can use them in the conversation with your business stakeholders, but also, most importantly, with the data science teams, so that you can help them understand how the model is performing and validate your model. Okay, now we can go ahead and make some predictions. I have a new data set which I received from the marketing team, which has information about my current customers. Okay, the data set is in S3, so we'll just upload the data set. It's this one, marketing customer list. Okay, again, we have similar information about our customers today, and we want to use this information to understand which of them are at risk of churn, so that the sales and marketing team can send them messages or run promotions targeted to them. So we'll import the data set, I will select it, and I go ahead and generate predictions. Okay, our results are ready. So we can view the results. And on the left-hand side, again, the first column shows us whether the customer is at risk of churn or not, and the probability. I can download the CSV file here. I can filter out anything that is false. I can keep those values that are true and share them with the marketing team. The other functionality I wanted to show you is the single prediction functionality. So here you can experiment with different values and see how these values impact the result, the prediction. So let's say that for this customer, we change the number of customer calls from 6 to 8. You can see that now this customer is at the risk of churn. You can do the same with other values, for example, the charge for the calls and the number of minutes. Amazon SageMaker Canvas also allows cross-team collaboration between your data analysts and the data science teams. So you have the option here that says Share with SageMaker Studio. And what you can do is that you can generate a link and share it with your data scientists. Your data scientists are most likely using Amazon SageMaker to create, train, and deploy their models. So they can open the link in their development environment, SageMaker Studio, where they are, and see the model, the metrics, and also the code behind this model. Now, in which cases would you want to share a model with the data scientists? First of all, maybe maybe they have some free time and they want to have a look at your model. Maybe they're interested to see the code or validate your model. Maybe it's a business critical use case and you want to get another view from an expert. In most cases, if you have a very good model, you want to also deploy to production. And what do I mean by that? You can put it behind an endpoint, and then that model can be used in an API, in an application, maybe in an internal tool, and other teams, other than yourself, can, for example, send customer data to an endpoint and get back information about whether the customer is at risk of churn or not. So these are the reasons why you would share a model with a data scientist. And if we switch roles now, and let's say I'm a data scientist, I can now go to SageMaker Studio and have a look at the link. Okay, this is this Amazon SageMaker Studio view, the development environment that data scientists use. They have all the information about the model, and they can open a notebook that has a lot of text and a lot of code that fully explain everything that happened around the data pre-processing and feature engineering part, data preparation part. They can also check all the different jobs that Canvas run behind the scenes, and they can go to the best model, take a look at the explainability report that has been generated. They can also see all the different metrics for the model in detail, and all the different parameters, hyperparameters we call them in machine learning, that were used when this model was generated. Okay, so we just saw two examples of how easy it is now to create machine learning models and add machine learning to your analysis with Amazon SageMaker Canvas. You can really scale machine learning adoption throughout your business, and what we hear from customers is that they think along the same lines. For example, the BMW Group uses artificial intelligence throughout their value chain to generate added value for customers, products, employees, and processes. Mark Neumann, who is the product owner in the BMW Group, told us that with SageMaker Canvas, business users can easily explore and build ML models to make accurate predictions without writing any code. He also highlighted that their central data science, it allows the central data science team to collaborate and evaluate the models created by business users before they publish them to production. Another customer is Siemens Energy. So Siemens Energy told us that bringing the power of machine learning to business users is at the core of their data science strategy. Specifically, Davud Naderi, who is data science team lead at Siemens Energy, mentioned that this approach will enable them to increase the speed of innovation and digitization of their energy solutions. He also pointed out that SageMaker Canvas is a great addition to their machine learning toolkit because it allows their business users to perform experiments while also sharing and collaborating with their data science teams. That way, they not only produce more models, those models reach production far more quickly. And at the same time, they adhere to the quality standards and policies that their organization has in place. At AWS, we focus on tools that help make machine learning accessible to everyone. And SageMaker is a central service to that. Amazon SageMaker has tools that help machine learning practitioners, machine learning engineers, data scientists, ML ops engineers to create, build, and deploy models to production up to 10 times faster than with traditional tools. And now with the addition of Amazon SageMaker Canvas, it brings all the SageMaker technology to business users. It also helps those teams collaborate with each other within the same environment. So you can really now scale your machine learning efforts and create value in hours instead of months, which was the typical approach before. I'm hoping that by now you may have some ideas about how you could use Amazon SageMaker Canvas and machine learning to solve some of the challenges in your organization. Even if you don't, I would encourage you to go back, have a look at your data, and think about what value you could extract from that data. To get started, I have added here some links that you can use, and feel free to take a picture. And also, you can go back and start experimenting now. Amazon SageMaker Canvas offers 2 months at no cost. And it offers interactive sessions of up to 750 hours per month. And you can train models, up to 10 models per month, and each with up to 1 million cells of training in the training data per model. I would also encourage you to get engaged with our training and certification content. So I don't know if you're aware, but we have the AWS Skill Builder. It's an online website that offers more than 500 free courses if you want to build your cloud skills. And also, I would encourage you to check out the certifications. There are about 11 certifications. One of them is in machine learning. They span from foundational ones to professional ones and specialist certifications. With that, I wanted to thank you very much for your time today. I hope you enjoyed the session and Amazon SageMaker Canvas. Thank you very much.